All right, so we've got significant digits. We're looking at importance of measurement first. So the next three videos are going to be all on significant digits and measurements, page 25. So you guys are going to be on 25 for this one. Objective point 4C, we're going to make and analyze measurements using significant digits to communicate accuracy and precision. So that's our goal with this significant digits. So we've got first qualitative and quantitative measurements. When you are looking at these words, you probably already can think through what they mean. So we've got quantitative, and the base word there being quantity, and so that is a numerical value, something that has a number associated with it. And qualitative, the base word there is quality, so a descriptive measurement. So those are the two different types of measurements that we can engage with and see. And so some examples, we're looking at something like the stove is hot. That is something that is descriptive. We don't actually know the details of that. We don't have any number associated with it. The oven was set to 350 degrees Fahrenheit. That's got a number with it, so it is going to be a quantitative measurement. Then we have something like the ice is cold, qualitative, because it's descriptive, it's quality. Mount Washington, 6,280 feet high. We've got a number associated with that, so quantitative. And John is sleepy, descriptive, so that is qualitative. Water freezes at 0 degrees Celsius. We've got a number associated with that, so that is a quantity, quantitative. And just a couple more. What do you notice here, though? You should notice that the numbers are the ones that are quantitative because they have numbers with that. So go ahead and try these here, pause the video, and see what you can come up with. We'll come back and check them. All right, so welcome back. We've got the house is yellow, that is qualitative. We've got Frank is 17 years old, number attached to that, so quantitative. Paul studied for 3 hours. We have a numerical value, so quantitative. And dog is barking loudly, definitely qualitative, because we are describing it without numbers, qualitative. Apologize. Then Alexis likes rock and roll music. That is qualitative also. And she has 94 rock and roll CDs. That's got a numerical value, so quantitative. Jill is getting tired, qualitative, because there's no numerical value. And has been sleeping for 38 straight hours. Numerical value, quantitative. If you missed any of those, definitely make note of that and see if you can ask me questions about that in class. So next, just a quick refresher, because these are going to come up pretty regularly in the measurements that we need to do. So scientific notation, if we are looking at something like 4,300 and, apologize. If we are looking at something like 4,302 and we want to put that in scientific notation, we need only a single digit to the left of the decimal, so that needs to be right after the 4.302 times 10, and we had the implied decimal right there, so 1, 2, 3 to get it there. Since my standard notation was greater than 1, it's going to be a positive exponent, so I've got positive 3 as my exponent here. Then if I've got something like 0.004302, in contrast, this is going to be same spot for that decimal. We need 4.302 because we need the decimal to be between that 4 and the 3. We move the decimal 3 times, So times 10 to the third. This time though, it is a less than 1 number. It's lower than 1. It's a really small number, so it is going to be a times 10 to the negative 3. You can also start with scientific notation, so 3.02 times 10 to the fourth. You need to get that to standard notation. We are looking at moving the decimal. Since it's a positive exponent, we're going to make this a larger than 1 number, which means moving 4 times this way, which means 30200, so 30,200 for that number. Okay, then addition and subtraction with those, quick refresher there. We've got addition. If I've got 2 times 10 to the second plus 3 times 10 to the fourth, and I need to add those two together, because it's addition, I need my decimal places lined up. In other words, I need my exponents to be the same. So then I personally am going to get to the larger number, so I'm going to move this one. And if I'm going to need to increase my exponent, I need to decrease my coefficient. So I'm going to make this decimal move to the left so that it'll get smaller in less than 1. It needs to do that twice so that I can go to a 4 for an exponent. So that'll give me 0.02 times 10 to the fourth. And line up my decimals. I've got 3 times 10 to the fourth, 3.02 times 10 to the fourth would be my answer here. Okay, and multiplication and division. If I'm looking at a number like 3 times 10 to the second times 4 times 10 to the third, I can multiply my coefficients. 4 times 3 is going to be 12, times, when I multiply my 10 bases, that means that I can add my exponents, okay? Which means that I have 2 plus 3 is going to be 10 to the fifth power. Not done here, because what do I need to do with this 12? To keep it in scientific notation, decimal needs to be right there between the 1 and the 2. So move it 1 time. Since it got smaller, my exponent is going to get bigger. I've got 1.2 times 10 to the sixth. Okay? And if you are unsure about how to do those, then definitely make sure you jump back to Unit 1 for a refresher on that scientific notation. It's going to be on every test here for the rest of the year, and it really comes in every single topic that we see. Graphing, we're not going to go too deep into that, but just the highlights here. You will need to know y equals mx plus b, the formula for a line. So you need to know that m is our slope, which means rise over run. And you need to know that b is our y-intercept. You need to be able to find each of those in a set of data, or be able to find that in a graph. Then last thing for us to quickly review is algebra. So just a quick refresher here. If we've got something like AB over C equals CD over equals CD, and I need to solve for D, then to do that I need to divide by C on both sides and divide by C, and I've got C will cancel, so I've got D equals AB over, and since I've got C on bottom and C on bottom, that'll end up being C squared. Okay, let me do another one real quick. If I've got AB over CD equals x over y, and I need to find y, then what I would do is I would go ahead and cross multiply. So I've got AB times y equals CD times x, and Again, I'm solving for y, not isolated, so I need to divide by AB. Get y equals c dx over AB. So that would be my final answer there. Okay? Then go ahead and try this one real quick. You've got xy over cd equals AB over G, and you need to solve for G. Go ahead and pause the video, solve for G, and we'll check it. Okay, then you should have G times XY equals AB and CD. So AB times CD. Need to divide by XY so that those will cancel. Divide by XY. The only thing I still have on the left is G, and that'll equal A, B, C, D over XY. Okay? Again, same thing, just like scientific notation. If you need help, definitely go back to Unit 1, see anything that you need from there. Let me know, or you can also go to Khan Academy, which is under the early finishing. If you have questions on there, they have great videos also on there. But again, let me know what you need from me. Either send me a remind or something like that, okay? So in summary, qualitative and quantitative measurements need to be able to know that qualitative is descriptive and quantitative is numerical. Scientific notation and algebra tie into that quite regularly. Make sure that you remember to take notes. Again, you guys are top notch with that. So thank you guys for being consistent. Awesome. Thank you guys so much, and look forward to seeing you. Bye.